So the output is a lactose juice. Juice means once you are fermenting the sweet potato with these glucose, inoculum size and fermentation. So after some time it creates a juice that is settled, that is some liquid form. That liquid form you are taking and you are estimating the lactic acid content in the juice as well as the lactobacillus brevis content. Okay. So I will show you the okay, you have to look at the runs. You can see 1 to 17. So I will tell you first how to generate the runs. So you can go for new design. So you can see the different values are there, no? Glucose, inoculum size, fermentation, 3 numerical values, no? 3 values here. This glucose, 3 are the independent factors. And there will be different units like a low, medium, low and high. You will not put medium, 0 you will not put. Here the glucose content in percentage, 0 and 10. The second one is inoculum size in percentage is 2 and 15. But ideally when you are looking at here, maybe 7 or 8, that is 0 value, that may be the ideal value for this particular product taken from the previous research, already published research. Then fermentation days 1 to 7, 1 block, it comes automatically 5 central points. And you are going for, there are different designs, central composite design, box binding design, optimal design and definitive screen design. There are 4 randomized designs you can do. There are other designs also you can do in split plot, mixture design, factorial design, because this is the design expert software. This is the so you can choose whatever you want to do. Then once it shows that there will be 17 runs, 5 central points, 3 factors. 3 factors means these 3: glucose, inoculum size and fermentation. So you go to next. Here units what? There are 2 outputs, responses. The unit value is mg per ml. Here also I will write mg per ml. Then you finish. So this is the design which is generated. So now you give the design to food technology. This is one experiment. Glucose percentage is 5%, inoculum size is 15%, and the fermentation day is 1. He will collect the data for the lactic acid content. After this, then brevis content. Then experiment 2, experiment 3, 4, 5, 6, 7, 8, 9, 10. Like that they will be collecting the data. Now we will take the previous one. I will show you because so this is the previous data. Here the data has been collected. You have to already entered. The data is already entered. Okay, now you have to do the analysis. So there are 2 variables here analysis. You can do separate analysis. Here optimization will be single, but the analysis will be separate. So here already analysis is done, but anyway I will do it again. Here no transformation. Here you can see if there is a non-normal data, you have to go for square root transformation, natural log or base to the 10 log, inverse square root. So what each and every transformation is applied to specific conditions. That's what I say, that before going for analysis you have to go for the data checking. Then once the data is perfect, then it is normal, then you don't have to go for any transformation. So here you have to click start analysis, but since it is already analyzed, it is not coming. Otherwise it will come. Start analysis, you have to click it. So now the fit summary. Here it is very, very important. This will give you which model you have to choose. It will tell you linear, 2 factorial and quadratic and cubic. Since the data is already, we already worked with the data, it is by default it is coming quadratic. But now 99% times it will not come like this. No. So it is suggesting The software itself is suggesting this is a good model. Here you can see adjusted R square and predicted R square. It should be, the difference should be less than 0.2. It is taken. Perfect. So you can go for the quadratic model. So here also you can see the suggestion software itself is giving the suggestion that you can go ahead with the quadratic model. So this is not required, you can directly go to ANOVA. So this is the very, very important. This table, this table, this table. Here you are very fortunate because software itself is giving interpretation. Whether it is correct or not, it gives you. Here also you can see it gives. Now it is significant. ANOVA is significant. If ANOVA is significant, you can look at the glucose, inoculum and fermentation. I think most of you know ANOVA, how to interpret ANOVA. Basic. Okay. So p-value, this all are significant. Interaction is not significant. This not significant, but BC is significant. Interaction BC is significant, and A square is significant. B square is significant. C square is significant. Lack of it should be non-significant. Here you can see model p-values 15.48 implies that the model is significant. There is only a 0.08% chance that F value is of this large due to noise. So that means that it says that it itself says that it is significant. You don't have to make an interpretation. Second thing is p-value is less than 0.5 indicate model terms are significant. In case of A, B, C, B square, the significant model terms value is greater than. It gives a guidance how to interpret these values. But it will not tell you lack of it should be non-significant. If it is significant, it is a serious issue. So you have to check the values and again you have to make it non-significant. Lack of it. Then you can come to, you forget about this, you have to look at this. Adjusted R square 0.89, predicted R square 0.69. So it is less than T. She itself says that predicted R square, it is in agreement with the adjusted R square, the difference is less than 0.2.
So it's a paid software, no sir? This one?
No, but the crack versions are there.
If you have crack
No,
versions, you
this
can
one
choose.
everybody has. You ask your food technology people.
Okay.
And here you can see this adequate precision. It gives why adequate precision is that it measures the signal to noise ratio. A ratio of greater 4 is desirable. You can use this content in making interpretation. Okay, in write-up you can, because it itself gives you the lot of facility, the software. So your ratio of 11.28 indicates an adequate signal. This model can be used for navigated design. Fine. So up to this we are fine. Now the coefficients of the quadratic model we have to identify this intercept, glucose, inoculum size. But it's not significant value will not be the corresponding significant you have to see here. Significant values you have to see here, but this is only the standard, the unstandardized regression coefficients. So glucose value, inoculum, and AB is negative, AC is less, and AB squares are minus. But only you can see that BC is significant. Other interactions are AC and AB are not significant at this level. So that means that we have a perfect model. Then you can go to diagnostics. Yeah, here I will tell you, if your model is not fitting, see this table. Here we expect that everything should be falling in line. There may be some, here you can see this value, originally it was here in our data. So we asked the person what they do for food technology, because the problem comes now, they make replicates. They make 3 replications, R1, R2, R3. So then when they make 3 replications, then for them it is much easier. Because we take either average value of the replication or any input individually, which one is fitting, that value you will use it. Because once you don't have replicates, only one value, you will be in serious trouble. But in our case, in the paper, they have taken average value. No? You go for 75 respondents, you take the average value of the pluses, average value of the other things. So naturally there will be a uniformity. So if the value, if this one is far away from here or here, from here or here, you will have a problem. The model will not fit. then you have to go back to the run. You put the cursor here, it will tell you the run number. See this one, I put a cursor here. So this is the run number 2. So you can check the response value. If there is a problem here, you can check the response value for the run number 1. So if this is okay, this is somehow coming into line. Otherwise, most of the problems will come when you look. If a problem is coming, you just government a normal plot of residuals. But if we are doing data preparation beginning itself, so there will not be any problem. Directly, you can there itself you will clear all outliers, everything. Then you don't have to come. But this particular software, it is not possible to do the data cleaning because you have to use follow only this method. Because if you go for other analysis in SPSS or maybe SAS or maybe in R, so that data you can do the data cleaning using the commands in SPSS or R or SAS. But here this data cannot be put into SPSS and we cannot do the analysis. So instead of that, we are checking all the normality in here itself. And here the distribution is fairly uniform. If the distribution is not fairly uniform, you have a problem. So the lines will be here, some dots will be here. So you have to go and click and identify the run, you check the value. So, and you can see this lactic acid normal plot of residuals. This is the predicted versus actual. Because predicted value and actual value should be very close. Like where we identified an R square value, adjusted R square and predicted R square, it should be less than 0.2. Still there is a variation, that the 0.2 variations are there, but it is acceptable. Because this is variation, these 3 red dots are there, no? It is not ideal, it should be in the line. So you don't have to think about this. Now we are coming to model graphs. So here you don't have to check all the model graph, only BC is significant. In this model, only BC is significant. AB is not significant. So we have to check only the BC. This is BC. Here, somewhere here you will find an optimal value. What you can do, this is contour plot. So I can show you separately. This is contour plot and this is 3D plot. Here, they will be more interested if you increase, here it will give you fermentation days, duration, inoculum size and based on that lactic acid content, this is the response. This is your variable, fermentation duration and inoculum size. But you have to put a cursor here and slowly move and you have to calculate, you have to identify the lactic acid value. It will come down here. Okay. So up to some level there will be increase and there will be decrease after some time. You have to identify the point. So you have to see up to which level the prediction is increasing. 7.4, 7.7, 7.9. Yeah, it is coming down. Somewhere here there is a highest production. So if you want this lactic acid should be the higher level production, you can tentatively identify using this which is optimal point. So up to which level it is, because interpretation, when you make an interpretation, you have to write it is increasing up to 7.9 and then again it is decreasing. So this is an interaction between fermentation duration and inoculum size. So this is a very tough task in responsiveness methodology. This you have to spend hours together to identify the exact points, at least the range.
So it will not give number.
Number we will get later, I will tell you. But right, this when you put this graph, in responsiveness methodology, attraction is this graph. If you don't give this graph, people will say, "Kya bhai, you don't have any responsibility." See, some prior requirements are there. No? Then when you cannot put this, simply put the graph. But 99% of the paper, they will write only 2 sentences about this interpretation. They will talk about the graph because it is done by food technology people. No, they are not done by statistician. Statistician means he will write more. But food technology people, the only thing is they want to show this graph, and every paper will have 6-7 graphs. Even non-significant also they will put the graph. So you have to create some show. That's what because it looks attractive, no? If it comes to the paper, then you think that the people are. But many papers, so many graphs will be there. Only 3-line interpretation of the graphs. But this is very interesting. I used to sit with the graph and see if any changes are there. I used to write because it will take time to understand. Then whatever we are finding in the graph, we will discuss with our partner, food technology. He will say, yes sir, I know, up to this level it has to increase, then you get capture decrease because they are technical people. No? Then we, after discussing with them, for this graph interpretation I used to write. They will not write. I will write from my side, then I will hand over to them, they will make it as a paper. Then I will show you the contour graph. This is contour graph. This is the interaction component, red. Here we will get a higher range. The lactic acid content will be very high in this range. So by color you can identify where the production is high. Then you can put the drawing here. So what happened? There are many papers that they will put this point. They told this is a central point. This 5 is not a central point. It is not an optimal point. In all graphs, the 5 will come. Some many paper I have seen people put 5 is an optimal point. No. It is showing the balance between this and this. That's why they put 5. But actually the optimal point or something you have to come somewhere here. Somewhere here you have to put the icon and see that, note down at every level you should have paper inside. Note down then up to what level it is increasing, what level it is decreasing. Because most of the papers as well as in when they explain the responsibility methodology, there will be little explanation about this. But this is a very critical component, critical part of the response surface methodology. But please remember, you have to interpret only the significant BC. Only BC is significant. But there are papers which the AB also they will, without significant also they will make interpretation. Okay, this is your graph and others. Now I will show you the optimization here. This point. So now you have to identify what is the range of variables, factors as well as the range of the responses. So the range is normally given by the food technologist here. But when you do social science research, you have to put the range from previous literature review. So here the range they are given 2 to 7, inoculum size is 2 to 10, fermentation duration is 2 to 5, lactic acid concentration 2 to 6. Sometimes you can see in especially response there are multiple options. Sometimes people will say that I want the maximum lactic acid. They don't give a range. Maximum lactic acid. Then you can put, or else you can put a range. Now we will put a maximum lactic acid. Then previous content also, let us put maximum. Okay, now you click the solutions. This is the optimal values. Glucose value 4.36, bioinoculum size 2, fermentation duration 3.3. If you put these 3 levels in the sweet potato, so you will get lactic acid of 4.39, previous content of 3 long 1. So this one you have to write in your optimal table. This is your output. This is the final output of response surface methodology. Now response surface will end here. When you make this from the data, you have to do 2 more things you have to do. You have to put this in equation form. Multiple regression equation we are writing now. Then the quadratic model you have to write in the equation form. Desirability factors you have to give in the table, and the final output, the desirability, the combination. Because this is the optimum level for which we have standardized the quality of this. Maybe you can say that if you put in a range, Suppose I put lactic acid is in a range. So 2 to 6. Breathe is also will let us put in the range. Okay, then you go for solutions. So whatever range you specified, the optimized value is coming here. Lactic acid as well as these. Suppose when you are making the color, lighting, pleasantness, that is your response variable. So you are making from 1 to 5. You want the pleasantness up to 4. And other variables up to 4 or up to 3 you can put in a range 3 to 4. Because we don't want unpleasant. It should be more than 3. So you put a value between more than 3. But getting those values, we don't know it is a psychological attribute. So we have to do some previous literature with you from color, because I am talking only in terms of the example which I have given. From the color, there are a lot of papers were published, ideal level of colors. So what is the ideal level of colors in a range? In a film theatre, what is ideal level of sound? Because there is some bass is there, bass and other combinations are there. Accordingly, you can identify the ideal level, then you can specify here and get the optimum value. This is one example I was telling, but there are multiple ways we can use the responsive method in our social science. But you have to find out where. That is an idea.
So can we use this RSM in attitude analysis, sir?
Attitude, if you are able to give the range, because we need continuous data. Response surface, your response variable should be continuous.
Because we are usually formulating the statements in 5-point continuum.
Yeah.
Can we put that 5-point continuum as the range and we can see?
Yeah, you can do one thing. You can go for unformed trials or FLD.
Okay.
3 different varieties.
Okay.
Okay, 3 different or 4 different varieties. You can select the farmer's preferred attributes.
Okay.
High yield, 3 levels of yield, like 20 tons, 25 tons, 30 tons. Then disease resistance, high disease resistant, medium resistant or low resistance. Some value you can put. Or else cooking quality. Some cooking quality you say that highly tasty, medium tasty and not tasty. So then you generate the designs, putting the value. Okay, then you can do your attitude towards a particular variety or adaptability. Attitude to each and every combination you will generate a value. Then you select the varieties and you put on a non-form trial or FLD. So when they are getting the yield, so you ask them that out of this combination you like it or this combination you like it, this combination. Normally we do in conjoint analysis. In conjoint analysis also we do the same thing, like we make 2 or 3 different levels of the variable, but there it is a conceptual product. It is not a real product. Yeah. So this is something you can think of. You can think of how it will be applied.
Marketing very useful.
Which one?
Marketing research.
Yeah, marketing research you have to think over where it, because so far response surface methodology was the property of technologies, but slowly it is coming to social sciences.
Even consumer preferability can be checked
but you
through
have
this.
to put the things in a perspective, means like a right way of selecting variables. And here what happens, you have to show the real combination. Here people are putting inoculum size and maybe fermentation days and salt concentration, those things. No, there is a tangible value, and when you use a particular experiment, some output will come. Maybe like you can ask them to taste it. So taste is a 5-point scale or 9-point hedonic scale. Taste is one of the area where, because I have done one MSc work with this, only based on sensory quality.
Sir, this is about food products, sir.
Yeah.
But many universities are now developing digitized products. Like, for example, if you take TNAU, they have developed AgriCart. It's an online digital platform for selling our products. So, if we want to measure that, can we measure it through this response?
Usability.
Usability.
Usability means you can put navigation speed, minimal, optimal. You can put it navigate maybe like absent of the navigation speed, and maybe like you first identify what are all the user preferred attributes in a digitized system. Like if you read the multimedia papers, no, like computers in human behavior and other journals, they will tell you in a multimedia usage like an expert system. It is an expert system. So what are the attributes you have to use it in a graphic user interface? So they have to choose something, no? Like a navigation screen is one aspect. Second aspect, the color of the user screen. Third one is maybe local language. So maybe font size. So from there you identify the user attributes in a graphic user interface. You identify the 2 to 3 levels or 2 to 3 different types. So then accordingly you put it in this, and the liking, responsibility or liking. Like even you can use for semantic differential scale, pleasant, not pleasant, or easy to use, difficult to use. Something like this you can put a scale, and from there you can optimize it. But it is a very good technique which will give you far better, damn sure. But you have to apply it properly. Because this is one of the Brahmastras of food technology. If you remove this thing, then Brahmastra will be very powerful. I will tell you, if you put responsible methodology, the food technology, definitely your paper will be published. Damn sure, all food technology journals are impact factor more than 7. No money is given. You know food technology? No money. It will go free of cost.
So time, how much time they publish it?
For technology, normally it takes 3 to 4 months. Last year we published one paper in LWT for technology. That took about 4 months time. But there, not only response-based methodology, we used, I will show you the methods. LWT paper also I will show you. So this is one paper we published in 2022. So this is the first paper we used artificial neural networks. Actually here so many people are there, it is not for decoration. Everybody has contributed here. These two are the people who did the experiment. So you see my name is the I wrote almost 45%, 70% of the total write-up. Dr. Deepak Mishra did the artificial neural networks. Actually, he did only and gave the results. Then I wrote the interpretation. Then Ram Prasad Sahu, Chandan Goswami has done this pre-clinical mouse model. These two. So, three are mouse model people. Selva Kumar, he is the guide, Sandeep Panda. He is the original ideator. He only coordinated everybody there. You see LWT, what is the rating? I think 4.1.